Hey everybody, Mr. Stewart here at Math We've Got This, and in this short screencast, what we're going to do is we're going to take a look at the exponent laws, at least an introduction to those laws. Okay, so let's take, for instance, this example at the bottom. So you've been working on this, so let's check in and see how it goes. So essentially what we're doing is we are going to multiply two powers together. So each power, notice, has k as its base. Exponents are different, but what's significant here is k is the base of the power. So as you patterned your way through, you ended up, let's change that to a pen tool. That would work a whole lot better. There we go. So the first power, k to the 3, k to the third power, that's 3 factors of k being multiplied. I'm going to use the dot notation to indicate multiplication. It's just a whole lot more convenient, a little bit cleaner in terms of expression. And then k to the 5th, right? 5 factors of k. The only thing slowing us down is the rate at which my tablet communicates with my laptop. And there we have it. So all together, count them up. We're multiplying 8 factors of k together. So that becomes a new power, k to the 8th. Now you likely noticed throughout all of the examples, and again, let me grab that highlighter, is this expression down here. So notice again, the powers have the same base. And also, change color for emphasis here, we are multiplying. Okay, so the general rule is when you multiply powers of the same base, we add the exponents. So that's x to the a plus b. And if you go back and look at the table you just completed and you examine each of those examples, I think you'll see that that rule applies. Okay, so in this video, the span of this video, short one, let's do one more. So let's zoom in on this. We can see it just a little bit better. And let's take the bottom one. So let's highlight a few things here. So we have p to the 8th power. So again, the bases are the same. Okay. It's important that you identify that because otherwise the rules don't apply. And then we are dividing. Okay. So we're going to find the quotient, which is the result after you divide. So let's write this out in a little more full length. That's expanded form. And we're going to have 8 powers of p in the numerator. So I'm going to switch to more of a fraction form of writing this down. So let's get those 8 factors of p written down. Again, there's that dot notation for multiplication. And then in my denominator, we will have 5 factors of p. I'm just going to line them up over here. You'll see why in just a moment. I'm kind of setting things up for myself so I can better show things off. Okay, there we go. Double check. We have 8 in the numerator. Yep, 5 in the bottom. Okay, next. Now, the interesting thing is that when you divide like factors, right, between top and bottom, and you've seen this before, guaranteed. So for instance, let me just kind of go this way for a second. Let's take a numerical example, right? So if I have 2 over 2, we know that if we divide each by 2, we reduce that to 1 over 1. Okay, of course, that is putting something in lowest terms. If we have a multitude of those factors, let's say you've got 2 2's in the numerator, and you have another expression where you have but 1 in the denominator. Okay, what we can do is we can still apply the same rule. What you do to the bottom, you do to the top. So if I choose to reduce this 2 over 2, so divide that factor of 2 by 2, divide the denominator by 2, and we end up with the following. So you'll notice that this first pairing of 2's, that's going to reduce to 1 over 1, or 1 times 2 over 1, for a grand total of 2. And it looks like we're running out of time in this free trial of our video, so let's circle back with a part 2.